Hey you, welcome back to your channel that is on JEE Physics. So we are going to solve JEE Advanced 2026 paper 1. So as usual, I will be bringing multiple solutions for each question so that the learning becomes complete. But my heartiest request to all of you will be, first pause the screen, look at the question briefly and try your own solution, and then only look for the solution. Your first target should be to solve this question on your own. Let us look at the first question. It is saying that consider a large disk of radius r, two smaller disks, each of radius small r equal to r by 50. Capital R is this radius of the bigger one, lying on a circumference as shown in the figure. The smaller disks are initially in contact with each other. Angular separation is delta theta between the centers. They are made of to roll without slipping. Very important word. So they are mentioning the condition of pure rolling in opposite direction with constant angular velocity of omega and 2 omega, while the large disk is held stationary. Find the time tau which the smaller disks are again in contact. So basically, since they are moving in the opposite direction to each other, so here basically we will use this formula that theta relative is equal to omega relative into tau. So tau will become theta relative by omega relative. This is going to be the working formula for the question. Now let us go for the solution. So first we are going to bring in method 1. There is hardly any difference between method 1 and method 2. One we are going to solve in terms of angular kinematics, another we will solve in terms of linear studies. So let us see. So here if you look at the question, if I draw this bigger disk one, and over that if you check the movement of the smaller disk, so let us say it is given in the question, it is rotating in the direction with angular speed omega 2. Let us say that is given as 2 omega. Now because of the rotation, it will have velocity in this direction, this taraf, tangentially here, right? So this velocity will be how much? This velocity will be equal to 2 omega. That means if I have to write in terms of omega 2, it will be omega 2 into smaller. Now if you look at the rotation about this center of the bigger disk, then this center of mass has some linear velocity in that direction. So if we take this distance, that is small d will be equal to how much? Capital R plus small r. Now if the rotation of this smaller disk about the bigger one, about this point, is, let us say, capital omega 2. So we can write here capital omega 2 is equal to d into so here velocity, what will be the velocity? Velocity will be in this direction, tangentially opposite. This velocity will be equal to capital omega 2 into d. That will be capital omega 2 into r plus r. We know in pure rolling, velocity of the point of contact, if this point is P, velocity of the point of contact has to be 0. So we can write omega 2 r plus r is equal to small omega 2 into r. So here hence omega 2 we get small omega 2 r by r plus r. Small r is given to be r by 50. So r plus small r becomes 51 r by 50. If you substitute, omega 2 becomes, I'm talking about capital omega 2, it will become omega 2 by 51, that is equal to 2 omega by 51. Similarly, by using the same convention, we can write omega 1 is equal to omega by 51. So if I use these two, then omega relative, since they are opposite to each other, pardon me, one correction. This is, we are talking about capital omega. So capital omega relative becomes omega 1 plus omega 2. So this becomes 3 omega by 51. Right? Now, let us come to the diagram once again. If you look at this diagram, then let us say that how much distance they will meet or how much distance they will cover. If this is delta theta, this is also going to be delta theta. So we can assume that the angular distance that they are going to cover, how much? Let's say if this is theta 1, if this is theta 2, so we are going to get the distance as theta 1 plus theta 2 plus delta theta plus delta theta, it makes it 2 delta theta. 2 delta theta, that is going to be 2 pi. So theta 1 plus theta 2 is going to be 2 pi minus 2 delta theta, and this theta 1 plus theta 2, this one is basically the theta relative distance. So theta relative, we got 2 pi minus 2 delta theta. Alright, fine. Now we have to find out this delta theta. This is easy to calculate. Think about this one. So this angle will be equal to delta theta by 2. Since they have asked us to use this approximation, small angle, so that means we can write for delta theta very small, what we can use? Sin theta is nearly equal to tan theta nearly equal to theta. So we will be writing sine of delta theta by 2, that is equal to, look here, this is perpendicular and this will be the base, this is small r, so it is coming r by d, r by capital R plus small r. When we approximate, it becomes delta theta by 2, that is equal to capital R by 50, and this becomes 51 R by 50. It gets cancelled. So delta theta by 2 becomes 1 by 51. Hence delta theta becomes 2 by 51. So this is the result that we are going to get for delta theta. Delta theta result here we got 2 by 51. So now we will be using this result and we will go back to this equation. So there theta relative becomes 2 pi minus 2 into 2 by 51. So that is 2 pi minus 4 by 51. That is theta relative. Alright? Yeah. Now next is very simple. You have to just substitute the data. So tau becomes, theta relative is 2 pi minus 4 by 51. Capital omega relative we already got. That was equal to this one, as you can clearly check. That is 3 omega by 51. Now let us use this result. That is 3 omega by 51. So finally tau value comes 51 2 pi minus 4 by 51 divided by 3 omega. That's going to be the answer for this question, and for that we will select third one as the correct option. Now the same question we can attempt by another method, by simplifying the situation in a much easier way. So since this is omega and this is 2 omega, I can imagine that this has a linear velocity tangentially in that direction as v, and this has a linear velocity tangentially in that direction as 2v. So since the linear velocity of the this is first one and this is the second one. Second one is more, so it will cover double the distance. So let us assume that somewhere here they meet each other. Here I'll assume to be they are meeting over here. So if I draw these two diagram, then this is one and there is the another one. Okay, right, fine. So let me make it more precise so that it becomes very clear for you in understanding. See, look here. So now I will take these distances. It's very simple to calculate. If this is delta theta, this is also going to be delta theta. My point is, if we take this distance, since this is very small, since it is given, since delta theta is very small, so I can assume that this center to center distance here it is 2r. So here also this distance is going to be 2r. What we are assuming कि this distance I will take to be s1, whereas this distance I will take it to be s2. So now if you think about this entire perimeter, how much it comes? It comes s1 plus s2 plus 2 into 2r. This 2r and this 2r, 2 into 2r, that is equal to 2 pi. How much? Capital R plus small r, outer perimeter. Now this will give us a clear cut idea. So s1 plus s2, how much it becomes? S1 plus s2 becomes 2 pi capital R plus small r minus of 4r, right? Yeah. Now we will be using this result as this is equal to V relative into tau. It is again a very simplified kind of solution that we are going to get. So then V relative will be how much? V relative will be equal to V1 plus V2. How much is V1? Omega into R. This will be equal to 2 omega into R. So this becomes 3 omega into R. Now, if we substitute the result, tau is equal to 2 pi R plus R minus 4R divided by 3 omega into R. Little bit of solution. We get 2 pi. 1 by 3 omega we can put outside. So let us keep 1 by 3 omega outside. Inside the bracket 2 pi R by R plus 1 minus 4. Put the values 1 by 3 omega 2 pi R by small r means R by 50 plus 1 minus 4. So again, if you can check, we are going back to this same result here only. So this becomes 1 by 3 omega, R gets cancelled, so it becomes 2 pi into 51 minus 4. If you take 51, this is out, so 51 2 pi minus 4 by 51 divided by 3 omega. This is the answer that we already got earlier. Thank you so much. Tune in for the next video.